This video is on measures of dispersion. Measures of dispersion measure how spread out a dataset is, and there's a few different ones that we can look at. So we have the range, which is the maximum value minus the minimum value. The standard deviation, and we use that symbol there, gives an idea of how data values are spread in relation to the mean. The variance, which is the standard deviation squared. The interquartile range, which is our upper quartile minus our lower quartile, Q3 minus Q1. Just a note there with the quartiles, so when we have the data values in order from lowest to highest, Q1 is the data point 25% of the way through the data, and Q3 is 75% of the way through the data. With this, we also need to be aware of outliers. So an outlier is a value that is much smaller or much larger than the other values. Now we can work out if a value is an outlier by using the formula of 1.5 times the IQR, the interquartile range, and then we add that to the quartile 3, or do the quartile 1 subtract the 1.5 times interquartile range to work out what that point is as to whether something's an outlier or not. And we'll do that in some examples. So example 1, for the following data sets, find the standard deviation, variance, range, interquartile range, and also if there are any outliers. So the first one, the number of ice creams sold over a period of 13 weeks is as follows. Here's our data. We want to find standard deviation first. Now to do this, we are going to have to do it all on our calculator. So we're going to go to the calculator, putting all the data, and then we'll be able to use that information to help find all these things. So on our calculator, we're going to go to the spreadsheet, and we're going to input our data into the first column, just like we would do normally to find the mean and median. Once we've got the data in there, we're going to do the exact same process as we have done previously. So menu, statistics, stat calculations, one variable. Our data's in column A, there's no frequency list, results in column B, which is all great. And we have our information here. So let's just go up to the top. We are wanting the standard deviation. Now, before we looked at the standard deviation symbol, so we need to find that in this title column here. So we have the mean, the sum of all the x. Now you see here, we've got two actual standard deviations. We have SX, and we have the symbol X. We always are going to go to the one with the symbol. This means population standard deviation. The S is sample standard deviation. We will always look at population and go across. And so you can see there, our standard deviation is 30.838. Now let's go back and put that in our notes. Standard deviation equals 30.838. which is 30.8 to 3 significant figures. Now our variance is always our standard deviation squared. So we want our standard deviation squared, so 30.838 squared. I'm just going to go back to the calculator to show where you can do it in the spreadsheet to work this out. In our calculator, the thing we've got to remember is this works exactly like Microsoft Excel. I'm just going to go to this cell next to it. Now I want this value squared. So what I'm going to do is I'm going to do equals just as I would on Excel. And this standard deviation value is in cell C6, so column C and row 6. And I want to square that. So I'm just going to go to the square button on my calculator, press enter, and you can see here it squares it for us. So we don't have to be going backwards and forwards to a calculator page from the spreadsheet page. We can utilize our knowledge of Excel to help in this. So I just did equals the cell C6 squared, and we've got our answer of 950.982. And then to 3 significant figures, that will round to 951. Our range is the maximum value minus the minimum value. So we can look at our data there to find it, but in case we are worried about making a mistake, we can go to our calculator and it has those values there for us. If we just scroll down further, you'll see here we have min x, so that's our minimum value. And if we go a bit further down, we also have our maximum value. So our maximum is 238 and minimum is 146, and we just need to subtract them from each other. Once again, if you wanted to do, you could utilize the spreadsheet functionality and we can do equals. Our maximum value is in cell C12 minus our minimum value, which is in cell C8. Press enter, and we got our range there is 92. And so it was 238 minus 146, which equals 92. The Fourth one we want to find is our interquartile range, which is, remember, Q3 minus Q1. So quartile 3 minus quartile 1. On our calculator, on this same area as where our min and max are, you'll see after our min, we've got quartile 1, Q1, and we have our quartile 3, Q3. And we just want to subtract them from each other to get our interquartile range. So we can go equals C11 minus C9. So our quartile 3 minus quartile 1, where those data values are. And our interquartile range is then 38.5. Now for part 5, we want to work out if there are any outliers. So what we're going to do here to work out if there's any outliers on the lower end, we need to use the little formulas we had before, which would be quartile 1 minus 1.5 times our interquartile range. So we know our quartile 1 is 150 from the spreadsheet, minus 1.5 times our interquartile range, which was 38.5. If we calculate that, we get 92.25. So any value lower than that would be classed as an outlier. And we can see from our data there isn't any, so there's no lower outliers. And then we do the same for the upper outlier values, but this time we do quartile 3 plus 1.5 times the interquartile range. So it'll be 188.5 plus 1.5 times 38.5. That will give us an answer of 246.25. If we look at the data there, the highest number is 238, so we have no outliers. Next example, 2 dice are thrown 100 times and their total score is recorded in the table, and we want to find all the same information. So once again, we're just going to go straight to the calculator, put this information in, get all of the values we need, and then we can work out our outliers. Into the spreadsheet, putting in the data, so our score is going to go in the first column, our frequency in the second column. So even though it's a horizontal table, we can still put it in vertically. So 2, 3, 4, 5. So once we've got our data in the first column, the score, the second column is our frequency, we can find our information. Menu, statistics, stat calculations, one variable, same as we've been doing. Our data values are in column A, our frequency list is in column B, so B and then control open bracket. And I'm going to put the results in column C just so it's close together. And here we have the data. So we scroll down, standard deviation, remember, is the symbol X. So it is a 2.80136. Our variance will be that value squared. So I'm just going to utilize spreadsheet functionality. So equals, this time my standard deviation is in D6. So it'll be D6 squared. And for my variance is 7.8476 or 7.85 to 3 significant figures. Our range is going to be the minimum minus the maximum. So equals, our maximum is in D12, which is 12, minus our minimum value, which is 2. So 12 minus 2. Obviously, most of you will not need a calculator for that, but that gives us a range of 10. And our interquartile range is our quartile 3, which is in cell D11, minus our quartile 1, which is in cell D9. And we get an interquartile range of 5. Now we know our interquartile range, we can then test for outliers. So I'm going to go back to our notes, put all those values in as our solutions, and then see if we have any outliers. So here I'm just going to write all the solutions rounded to 3 significant figures. As remember with the IB, that's how we always like to give our final answers. All right, outliers. So the lower one, we want our quartile 1, which is 3 minus 1.5 times 5 to give our lower bound for quartiles. which would be negative 4.5. We don't have a value lower than that, so there's no outliers on that end. And then we want to check the upper, which would be our quartile 3, so 8 plus 1.5 times 5, which gives us 15.5. Our highest value is 12, so once again, there are no outliers. The last one, the weights of 50 cats are recorded in this table, and we're going to do all the data. So we have our table here, but we'll notice it is a class interval table, which means for our spreadsheet, we need to have our midpoints also to be able to put it into the calculator. So we want our midpoints of our weights. So the midpoint of 2 and 3 is 2.5. Midpoint of 3 and 4, 3.5. And we just find all our midpoints. And when we put it in our calculator, we put the midpoints and the frequency. There are 2 columns. Just put the data in. So I'm going to put my midpoints in the first column and my frequency in the second column. And once we've done that, let's calculate our statistics. Complete this. So our data values are in column A, our frequency is in column B. Results to column C, all good. And let's find out information. So we want our standard deviation first. So we're looking for the symbol. So our standard deviation is 1.1. Our variance, we want to square 1.1. So we're going to do d6 squared. So you could do d6 squared. You could also do d6 times d6. That would also give you the same answer. 1.21. So our standard deviation 1.1, variance 1.21. And then for our range, we've got our max minus our min, so 7.5 minus 2.5. Once again, you could put the cell-ins. You could also just put the numbers because they're exact numbers. So you could just put the numbers into the spreadsheet as well, another option. And our interquartile range is 4.5 minus 3.5, so that would give us 1. So our range is 5, our interquartile range is 1. With putting just numbers in here, you can only do that if these are exact values. So that is exactly the 7.5 and 2.5. Otherwise, I would recommend putting in the cell number, as if it is a decimal that's been rounded, we want to use the exact values. We can go find out if we've got any outliers. Outliers, the lower outlier will have quartile 1, so 3.5 minus 1.5 times our interquartile range, which was 1. Which equals 2. So anything less than 2. Now here, because we've got a class interval table, we can't really see if there's any outliers because we don't have the actual data. But because our lowest value would be 2 if it was possible, and it's anything less than 2 that would be an outlier, we know there's actually no outliers on the lower end. And let's see if there's any possibility of outliers on the upper end. So we have our upper quartile, which is 4.5 plus 1.5 times our interquartile range, which is 1, which equals 6. So in this situation, we would have some possible outliers because anything greater than 6 would be classed as an outlier. So from our table, definitely the 1 that I've just put a square around because that's between 7 and 8. Now the 3 here, between 6 and 7, they could be an outlier, they may not be an outlier, because if all those 3 values were 6, then they wouldn't be outliers because it's everything above the 6. So in this case, not sure if those 3 would be outliers or not. We'd need the exact data, but we do know there is definitely at least 1 outlier in the 7 to 8 range. So we know there's definitely some outliers, we're just not sure how many. Usually with outlier questions, you wouldn't be asked it in a grouped data table like this. It'd be more like in the situation of part A and part B, the ones we've just done before. Last little part here, to be aware of that sometimes you may be asked to add or subtract a value from each of the numbers in a data set, and we need to know how that will affect our mean, median, standard deviation and variance. So if we add or subtract k from each of the numbers in a data set, then the mean will increase or decrease by that same value. And that is the same for the median. And the standard deviation and interquartile range would not change because the spread of data is still the same. So if we added 1 to every number, the spread of data from the smallest to largest stays the same. Therefore, standard deviation, interquartile range, variance would not change. But if we multiplied each number in the dataset by a certain value, then the mean, median, standard deviation, interquartile range will also multiply by that same value. So just quick examples to work those out. Part A, the mean of a data set is 12 and the standard deviation is 15. If 100 was added to every data value, what will be the new mean and standard deviation? So the new mean, if we're adding 100 to every data value, it also means our mean will have 100 added. So our mean is 12 and we're adding 100 to everything, so we'll also add 100 to the mean, which means our new mean would be 112. And the standard deviation would stay the same, that would stay as 15, because we haven't changed the spread of the data. The spread of the data is exactly the same, we've just made all the numbers bigger. At B, the median is 2.4 and the interquartile range is 3.6. If every data value is halved, find the new median and interquartile range. So with the median, if every data value is halved, that means the median will also be halved. So it'd be 2.4 times by 0.5 or divide by 2, whichever way you want to do it. And so our new median would become 1.2. And our interquartile range would also be halved, because the spread of the data is going to decrease by a half. 3.6 times 0.5 or divide by 2, which gives us 1.8. And that's the end of this video on measures of dispersion.